Okay. So this is a non-homogeneous system because of this one, vector G here. The vector G make it become non-homogeneous system. To solve non-homogeneous system, first step means the solution. Step 1, you have to solve your homogeneous system. Solve your homogeneous system. To solve homogeneous system, you need to get actually the complementary function. Let's say YC. Okay, you want to get what is the YC. Okay, to get your YC, okay, as we solve the homogeneous system, first step, okay, so you have to get the eigenvalue. To get eigenvalue, you will let the determinant of A minus lambda I equal to 0. A minus lambda I equal to 0. Okay, so determinant. So for matrix A, the main diagonal is just minus with lambda. So this is 3, negative 2 minus lambda equal to 0. And then you calculate the determinant. You have 5 minus lambda times negative 2 minus lambda minus product of 3 times negative 2, which is negative 6 equal to 0. So you have negative 10. You expand slowly. So you have minus 5 lambda. So this one plus 2 lambda plus lambda squared plus 6 equal to 0. So you have lambda squared. So negative 5 lambda plus 2 lambda. So minus 3 lambda. So negative 10 plus 6, negative 4 equal to 0. And then you factor it. Minus 4 plus 1. So negative 3 lambda. So you have lambda 1 equal to negative 1. Lambda 2 equal to 4. So first step for solving the homogeneous system, you have to find the eigenvalue. Okay, after you obtain the eigenvalue, okay, this is step 1A, getting your eigenvalue. Okay, after you get the eigenvalue, 1B, find your V1. First eigenvector V1. Okay, to find V1, you substitute A minus lambda 1 I V1 equal to 0. So from here, okay, determinant is straight, okay, and matrix is round. So 5 minus, okay, lambda now plug in lambda 1, which is negative 1. So 5 minus negative 1. So this is negative 2, 3. So negative 2 minus, okay, minus negative 1. V1, let it equal to xy equal to 0 vector. So you have 5 minus negative 1, 6, this is 3, this negative 2. So negative 2 plus 1, so negative 1, xy equal to 0. So you notice that if row 1 here, row 1 you divide by 2. If row 1 you divide by 2, row 2 you maintain. So 6 divided by 2, you have 3. Negative 2 you divide by 2, you have negative 1. Then this is xy equal to 0. So that's why row 1 is actually equivalent to row 2. In 2 unknown, but we get to only one equation, which is 3x minus y equal to 0. So you let y equal to 3x. Once clear, let x equal to s, so y will be equal to 3s. So you have two unknown with only one equation. First, we have infinite many solution. So this is a xy. X is actually 1s, y is 3s. So your okay. And just now we all mean you have infinite many solution. By taking s equal to 1, our v1 is actually 1, 3. Because we let v1 is xy and we let s equal to 1. Exactly, if we let s equal to 2, we have another version of v1 and so on. That's why, because two unknown, you have unique solution which will have two equations, but here only one equation. That's why you have infinite many solution. This is one of the solution. So you have v1 is 1, 3. So later on you find the v2 in step 1c, find your v2. Similar step, okay? You plug in, okay, here. Similar step with S1, step 1b. You just replace your lambda 1 now become lambda 2. Lambda 2 which is 4. So by solving your a minus lambda 2 I v2 equal to 0. Okay. In the a we have here 5. Okay, lambda 2 is 4, so 5 minus 4. And then this is 3. This is negative 2. Negative 2 minus 4. v2 also we let it equal to xy equal to 0. So 5 minus 4 is 1. This is 3. Negative 2. Negative 6. xy equal to 0. Okay, you notice if row 2 I divide by 3. Row 1 I didn't change anything. Row 2 I divide by 3. So 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. So xy equal to 0. Against K2 unknown. Okay. So means here row 1 equivalent to row 2. The same thing. Row 1 and row 2 are actually represent the same equation. Mean two unknown is left to only one equation, which is x minus 2y equal to 0. Okay. So in this case, if I let x equal to 2y, then letting y equal to s, so x will be 2s. So you got x, y. So x is 2 s, you factor out, y is 1s. So letting s equal to 1, you get your v2 is actually 2, 1. Okay, that's why your yc is actually a v1. v1 is here, 1, 3. Exponent lambda 1. Lambda 1 is actually negative 1. So a negative t. Okay, plus b v2. v2 here, 2, 1. 2, 1. Okay, lambda 2 is 4. So 4t. Okay, that's why so you get here. This is a, this is v1, exponent lambda 1 is negative t, b, this is v2, exponent lambda 2 is 4t. So this is solution of homogeneous equation, or you can, this is the yc. This part is yc. And then we need to find yp. So add up yc and yp. So this is a general solution for your non-homogeneous system. Okay. So we get yc already. So any questions before we proceed to the non-homogeneous part, the yp.
No, Doctor.
Okay, your your vector G you have actually exponent 2t and 10. Okay, when we have exponent 2t exponent 2t 0 plus this 0 10. So mean you have actually vector G is a linear combination of exponent 2t. This is exponent 2t, this is a constant. So you choose your yp. Okay, if exponent 2t, here or ab, so you choose this is cd exponent 2t. Okay, this is constant, so cd and then this will be e f. Yeah, we choose yp based on your vector g. Vector g here is exponent 2t, so your yp also you must have a exponent 2t, and the coefficients here is going to be determined later on. So we already have a, b, so here I use c and d. And then this is constant vector, so a yp also must have a constant vector. If the g here is polynomial of degree 1, hence you must have a vector of polynomial of degree 1 too. Okay, so any question for choosing the yp here? Any question or not? Okay, if you don't ask, later on, some of you will choose a yp based on yc, like you did, I think, the second order. Choose yp based on g. If second order, choose your yp based on the fx in the right hand side function. Don't choose yp based on the yc. So you choose based on the vector g. After you choose the yp, you have to check. This is a exponent 2t. This one is exponent negative t, exponent 4t. So this one not clash. Okay, this is constant. Here we don't have constant, so also not clash. Is it okay? If not clash, then you just differentiate. Okay, and here you just need to differentiate one time, because this is a system. We have put properly y prime equal to a y plus g. So just need to differentiate one time only. So this is first order. Okay, then you have the yp prime. Okay, differentiate exponent 2t, you got 2 times. CD is a constant, so 2 times CD, constant vector of CD. So exponent 2t. Okay, differentiate constant 0. So this is your y prime p. Okay, the y prime p will be plugged in into your our non-homogeneous system is y prime equal to a y plus g. Okay, y prime is actually 2 times of your CD exponent 2t. Okay, a is 5, 3, negative 2, and then negative 2. Okay, y just now that we choose is here. CD exponent 2t plus EF, okay, plus G. Okay, G just now, G is here. Exponent 2t, here, put it here. I can break it here because I got no space, I combine back. 2 times of CD exponent 2t. Okay, this is a matrix 2 times 2. Okay, this one is 2 times 1. Okay, this is plus. Which one close properly? This is A, this is Y, this is plus G. In matrix A here, you multiply Y, you have actually linear combinations of exponent 2t vector plus a constant vector. So mean, if you confuse you like this, you take here 5, 3, negative 2, negative 2, vector A times this Y. So you got CD exponent 2t. Okay, but this is plus, so vector A times this constant vector. 5, 3, negative 2, negative 2 times E times F. Okay, add up with exponent 2t and 10. Then you need to do matrix multiplication. Here 2 times 2, this is 2 times 1, so okay, 2 equal to 2 here, so these two matrices can be multiplied and the result is 2 by 1, so same with this one, 2 times 2, 2 times 1, 2 equal to 2, so the result is 2 by 1. Then you do the matrix multiplication, you have click here, first row times first column, so you have 5 times C minus 2 times D. So the result is 2 by 1 vector. The exponent 2t just put outside. So you got 5c minus 2d. 5c minus 2d. Okay, second row times first column. That's why I get here second row first column, which is 3c minus 2d. Okay, add up with this one. 5e minus 2f. 2f. This is 3e minus 2f. Okay, and then this is exponent 2t 10. So you may collect exponent 2t to here, 10 to here. That's why you collect this term collect together. Exponent 2t is at the first row. So 5c minus 2d, this one I got one time of exponent 2t, so plus 1. So exponent 2t. Second row, this is constant, so this one don't have any changes. 3c minus 2d. Okay, this is a constant vector, 5e minus 2f. Okay, 5e minus 2f. First row, this exponent 2t already collect here, plus 1. Okay, 3e minus 2f, okay, collect with this 10, so plus 10. Okay, and then you compare. Okay, left side 2c, 2d, exponent 2t. Then you compare, okay, our purpose is actually we want to solve for what? Okay? C, D, E, F. So we should have 4 equations to solve 4 unknowns. So first of all, I'm going to compare the exponent 2t vector. We compare this one and here, left side, right side. So for exponent 2t, first, I take first row, 2c equal to 5c minus 2d plus 1. Okay, this is the first row. Okay. 2c equal to 5c minus 2d plus 1. So total, we have to collect this one to here. I should have 3c minus 2d equal negative 1. 1 the other side. I bring 2c to right side. So 3c minus 2d positive 1 bring to the other side minus 1. This is equation 1. Okay, for exponent 2t, the second row you have 2d. 2d equal to 3c minus 2d. Okay, so means c minus 2d equal to 0. This is the second equation. Solving 1 and 2, okay, you should be able to get c and d. at this one I make a mistake. This is 3C, 2D. Bring to this side, so minus 4D. So you can think, okay, add up these two equations easily. Okay, it takes 1 minus 2. 3C minus 3C, no more. Negative 2D minus 4D become 4D. So 2D equal to negative 1. So D equal to negative half. Okay, solving 1 and 2, I get D is negative half. Okay, after I get D equal to negative half, okay, plug in back, you get the C. Okay, or you may use your scientific calculator to solve it quickly. Okay, then you press your scientific calculator. Mm, 3, negative 2, negative 1, and then this is 3, negative 4, 0. So okay, x is actually the C, which is negative 2 over 3. Negative 2 over 3. D is actually the y is negative half. So you obtain C and D already. Okay, and you're solving the constant term. Left side we don't have a constant, so mean phi e minus 2f equal to 0. So this one, okay, you're solving this one. Constant term, left side we don't have constant term. So straight away, mean the constant term, let it equal to 0. Okay, I'm using the scientific calculator to solve it quickly. So mean, okay, this one, in one space, you can see. So you have actually, okay, constant term, left side you don't have, so you let phi e minus 2f equal to 0. This one, you let it equal to 0, you have 3e minus 2f equal negative 10. So you may use a scientific calculator to solve it quickly to get your e and f. You put phi negative 2, 0. Phi negative 2, 0. Second row 3, negative 2, negative 10. 3, negative 2, negative 10. So x is actually my e. So e is, okay, this is solution. E is phi. E equal to phi, and then the y is actually my f, which is 25 over 2. So f equal to 25 over 2. So yp just now we said is actually what? CD exponent 2t plus EF. CD exponent 2t plus EF. So plug in CD value. C negative 2/3, D is negative half, exponent 2t. Plug in the E is phi, F is 25 over 2. So this is the YP. And then your general solution for non-homogeneous system. Okay. For your, okay, just put non-homo system. Will be the Y is actually your YC plus YP, which is basically given here, YC. plus this yp. So, any question? Because time also almost up. Any questions? Okay, this one for non-homogeneous system. This case you have a combination of linear combination, exponential function and constant. Okay, the rest of the equation, okay, for proving part of the application you can skip, because in the we are not going to ask you to prove it, we are just solve it directly. You may skip the derivation on how to get this non-homogeneous system. Okay, this case, this one is, okay, for question 9a here, this case your vector g is constant. Okay, g, okay, this one, g is constant. Then you choose your, this one is solving for I1, I2. So this will be IP. You choose IP also, let's say constant term C and D. Okay, but you have to check whether your IP clash. Okay, so clash with IC. This is the IC. So IC is exponential term, so not clash. So you just need to differentiate to get the I prime, which is 0, 0. So you plug in your I prime P. So mean this system is actually your I prime equal to AI plus G. So I prime you plug in 0, 0. Okay, and then you plug in your matrix A, I1, I2. This is negative 10, negative 20 over 3. This is 10, 98 over 15. The I is actually, we assume is constant C, D plus the G, okay, that we, G is this one, 5, 10 over 3. So in this case, so you have two simultaneous equations. So okay, the constant term bring to your right hand side. Then using your scientific calculator, you can solve your C and D quickly. This is question 9. Let me see. Okay, question 7 also, this is constant term. This one also constant term. But I think classing. So it's multiplied by T. This one also constant term. Question 4 also constant term. This is a homogeneous system. This one homogeneous system. So any questions? Okay. Then tomorrow I'm going to let you view the YouTube for the application question. Then later on we will solve, okay, continue solve the homogeneous system and non-homogeneous system. And next week we are moving to the Laplace transform.